So, welcome to one of my first videos ever. I have never vlogged anything, so I'm super amateurish in this. And I'm also in a location where it's not so easy to have like a white wall and make everything look super clean because I am in my summer house in Sweden. It was built in 1800 something. I don't know, it's really, really old. But it's a very beautiful location. We're directly by a lake. There's nobody around for like kilometers, and it's a really really nice place to be in. So please excuse my lack of professionality in this video. But I anyway wanna do these kind of videos regularly, actually, um, because I want to talk about a lot of things that are related to IOTA. Um, One of the reasons is that I have the feeling that a lot of people who are active in the crypto space, be it competitors or investors or like just people who are interested in the technology, have a certain perception of IOTA and don't really understand the technology or misunderstand the technology. Um, and then there's also another reason, which is that I want to give people the chance to get some insights about the developments that we're working on at IOTA in the background that might not be finished yet, so they are not worth a blog post, or they're not completely done yet. But I would still want people to have the chance to actually understand what is being worked on behind the scenes, because it makes it easier to understand why certain things take a little bit longer um, than we anticipated eventually. Um, and I also want to use this format or like these kind of videos to give people the opportunity to ask questions, for example, by providing comments in the videos, so I can proactively decide what might be an interesting topic to talk about. Today is going to be actually quite easy to understand what I'm going to talk about, but it's also going to be interesting because it has certain implications. Um, and the question that I want to talk about today is actually a very fundamental one, and it is, why is IOTA's Tangle the way, designed the way it is? Like, why do we have a DAG where one transaction references two other transactions? And to answer that question, we need to understand what IOTA tries to be. IOTA tries to be a solution, a protocol that enables devices, machines, also humans by using machines, for example, to reliably communicate in a decentralized way. Um, and of course, as a second step, also to enable them to transact value. So in contrast to other distributed ledger technologies that focus mainly on the value transaction part, IOTA aims to also be a reliable and efficient way to exchange data, because that is equally important in the near future when you have sensors everywhere and data is being produced all the time. Then people will also be interested to monetize this data. Um, so this is like tightly related. I think designing a DLT with only this one particular use case in mind is giving away a lot of potential. Like the decentralized future that I see does not only use decentralization for value transfer, but for everything. And to understand why the IOTA Tangle is designed the way it is, we need to ask a certain question. What does decentralized communication even mean? Um, After all, the non-decentralized communication that we have today, where stationary devices talk to other stationary devices, we already have very successful protocols like TCP/IP, for example. Um, if we if we look at how decentralized communication is achieved today, we will most of the time see a certain form of a gossip protocol, where one node tells his information to another node, and then he tells this information to all of his neighbors, and they tell it to all of their neighbors, and so on. And this protocol is actually extremely simple, and has a few very really nice properties. One of the properties, for example, is that it scales extremely well. Like my messages arrive at other nodes in an upper time bound, no matter how many nodes I have in the network, essentially. So if I have like 100 million nodes and I exchange messages through gossiping, then I can be sure that after a certain amount of seconds, everybody should have seen this message. Um, Now, if that works already so good, then why do we need the IOTA protocol? And this is where it becomes tricky. When we talk about decentralized communication in the IoT realm, then we talk about decentralized communication in an environment where connections are not reliable. That means that you will always have a certain amount of members or participants of this communication process that are not online. That could be because a car is driving through a tunnel, for example. It could be because devices try to save energy and go offline every now and then. But we will not have the same homogeneous and reliable infrastructure that we have today in the internet. And anyway, relying on a reliable transaction like medium for exchanging information, even for the internet, might be problematic. Um, so I just want to conclude this with a short example. Let's say we use traditional blockchains, for example, and in the case of Bitcoin, for example, to exchange messages in this way. So if everybody sends its message to all of his neighbors and it distributes extremely fast, then this is essentially no problem as long as everybody is online. But once somebody goes offline, he will not receive this information. And even if he goes online after, he has no way of finding out what everybody has been talking about in the past, because he has no way to ask for the missing transactions. The only way for him to catch up is to wait for a miner to mine a block, then decide what goes into this block, and therefore define what is part of the ledger state, then send this block out, and therefore give the person who was offline the opportunity to catch up with everything that happened before. But he's not catching up with everything, he only catches up with what the miner selected, which is a problem because miners can lead to centralization. We have the problem that miners can actually censor stuff, like if they decide to not include certain addresses from certain individuals in their ledger, and we would, for example, assume that a cryptocurrency is used as the world currency, then it is not so far-fetched to assume that some actors might collude their interests to censor certain other countries or certain other individuals, for example. So this is not a very good approach if you want to have a censorship-resistant, decentralized way of communication. So how does IOTA solve this problem or tackle this problem? Well, we have thought about a mechanism that would enable this without all the drawbacks of the blockchain. And the basic idea is the following. If every transaction references another transaction, then as soon as the person who was offline goes online again and sees a recent transaction, he can ask for all the missing transactions that happened in the meantime, and therefore catch up without having to rely on a centralized entity that tells him what the conversation was about. So this is extremely powerful already in itself. Now, if we only have one reference, then this becomes problematic, because if we have like 1,000 people talking at the same time, then we would essentially have to reference every message from every single person, would have to reference every other message, and therefore everybody there would be a situation where only one person at a time can talk. Like, I need to synchronize those messages to be able to chain them together. So this does not work very well, especially if you assume you have like nodes in like the tens of thousands or hundreds of thousands. So what is the next logical step? Well, if one reference is not enough, then what about two references? And here it becomes interesting, because two references suddenly allow me to reference an exponential number of other messages that happened in the past. That means just by going from one reference to two references, I am able to reference an arbitrarily high number of other messages that are happening between other decentralized entities. So that means that the IOTA protocol is most probably the most efficient way to enable a reliable decentralized communication between peers in an unreliable medium. It's a pretty bold statement, but I don't think that you can get much better than that, because referencing the transactions is extremely easy. So you just hash the transaction and you include the previous hash. So it's extremely simple, it's extremely straightforward. Interestingly though, this simple protocol already brings with it a lot of the features that you have to pay somebody to do in the blockchain world. Um, One thing is, for example, that it ensures immutability because we use hashes of transactions to build the references. Changing even a single bit in the transaction will change the hash completely, and it will break the whole chain of hashes of all the transactions that referenced it. So that means that it is impossible to change anything down the line, and we don't have to pay anybody to achieve this. It just emerges automatically. Then another feature that we get is this censorship resistance, because even if I'm a very powerful node or whatever, and I decide to not reference this particular transaction, as soon as somebody else references it, and somebody else references their transaction, if I really stick to my idea that I won't process this transaction, then I will just at some point have no opportunity to attach anything to the Tangle anymore, because everything else references this transaction that I would like to censor already. So it is very censorship resistant. It ensures the immutability of data. And another interesting aspect is because transactions reference past transactions, it also defines a certain order. It's not a total order, and we will have to address that in the consensus mechanism, but I already have a certain perception of what happened when. So if we sum this up, is what the IOTA protocol, the Tangle, it's just a Tangle. The IOTA protocol is something that builds on top of it, but the Tangle is most probably the most efficient way to enable decentralized, reliable communication. And what this means is that all the nodes that are taking part in the network, even if they are online or offline for a certain time frame, come to more or less the same perception of when things happened. And that's most of the tasks that a miner has. He defines an order, he defines what becomes part of the ledger, and he therefore is not really censorship resistant. Yeah, but there's only one last thing left that you need to solve on top of this data structure, which is deciding which one of the double, like if somebody double spends, which one of the two conflicting transactions get included. And it's not an easy task. It's something that we're going to talk about as well. But anyway, this very basic and very fundamental protocol already brings with it 90% of the tasks that usually the miners perform. And this happens completely free. Like, there is no cost involved in this whatsoever. I mean, of course, I need to issue my transaction. I maybe need to do some proof of work as a spam protection. But other than that, I don't need to pay anybody. I don't need to rely on anybody. I can just broadcast and communicate in the network freely without having to wait for anybody to process and validate my transaction. And this is extremely powerful because it enables DLT to be used not only for value transfers, but for pretty much everything. Like, I can send information about traffic details, congestion. I can send information about the temperature at a certain location, for example, and all of this is immutable. So this is an extremely powerful concept, and this is the reason why the Tangle looks like the Tangle. And even though this is a very basic and fundamental thing, I think it's extremely interesting. And I want to conclude with that. And I'm really interested to see if people think it makes sense to talk about these things, if they think that we should continue with this. Yeah, just give me your feedback, and next time I will talk about something else.